Hello, I'm Morgan Bright, and this is my Data Networks interview questions preparation project for ITM431. Starting off, we have the OSI model and the purpose and why we even use this thing. So the OSI model is a 7-layer reference model for network communication, and this provides a standard for how different network systems communicate over a network. Each layer provides specific functions to facilitate the reliable data transfer and easier troubleshooting. Beginning with layer 1, we have the physical layer, and this deals with physical processes like transmission media, connectors, signaling, and the physical structure of the network. Next, we have the data link layer, layer 2, and this standardizes data link processes such as frames, switches, wireless access points, and managing communication over a single link. An example of this one would be the Ethernet, which controls how data is formatted for transmission. Layer 3, we have the network layer, and this will manage logical addressing, routing, and forwarding data across multiple networks using protocols like IP, which is going to predict logical addressing and routing. And we have layer 4, the transport layer, which ensures end-to-end communication, providing error recovery, flow control, and reliable or unreliable data delivery via protocols like TCP, which is reliable, and UDP, which is unreliable. In the session layer, layer 5, this will coordinate and manage sessions or ongoing communications between applications, including setting up, maintaining, and tearing down connections. For layer 6, we have the presentation layer, and this translates data formats, manages encryptions, compressions, and ensures data from the application layer is usable by the network. So an example for this one would be TLS, which is used for a secure connection. And lastly, layer 7, the application layer. So this interfaces directly with end user applications, supporting network services like email, where we have SMTP, we have web browsing, HTTP, and file transfers, FTP. Walk me through how you would build a small network LAN, and what are the main components, and what do they do. So starting off, we would plan the network layout, which would be defining the devices, server roles, and the internet connection needs. Next, we're going to set up our main components. Starting off, we have the core switch, which is the central hub connecting all of the devices. Then we have our work group switches, which connects end users' devices like PCs and printers. Then we have cables that use Ethernet cables to link devices to switches. And we have wireless access point swaps, which provide wireless access for mobile devices. And we have our router with NAT, which connects LAN to the internet and translates IP addresses. And we have our firewall, which is going to protect the network from external threats. We have our DNS server, which is going to resolve domain names to the IP addresses. And lastly, we have the DHCP server, which is going to automatically assign IP addresses to the devices. So our third step is going to be establishing an internet connection. This is when we connect the router to an ISP modern. Next, we're going to configure network settings. So we're going to set up IP ranges, DHCP, DNS, and firewall rules. And lastly, we're going to test and optimize by verifying connectivity, optimizing Wi-Fi placement, and monitoring the network. So what is Telnet? Telnet is a network protocol used to remotely access and manage devices, typically through a command line interface. The purpose of Telnet is to allow users to connect to a remote device or server and execute commands as if they were physically present at that device. Some limitations of Telnet is that it sends data, including usernames and passwords in plain text, which makes it not secure for use over the network. And the port is going to be port 23. So for SSH, Secure Shell, it's a cryptographic network protocol for secure remote access and management of devices. So the purpose is to provide encrypted communication to ensure the data confidentiality, integrity, and authentication, making it ideal for remote administration and secure file transfers. An advantage of SSH is that it's more secure than Telnet because it encrypts all communication, protecting against eavesdropping and interception. And the port for SSH is going to be port 22. What is the difference between asymmetric and symmetric encryption? So symmetric encryption is a single key use. It uses the same key for both the encryption and the decryption. Symmetric encryption is fast and efficient because the process involves only one key. A key management issue is, though, that since both the sender and the receiver must securely share and store the same secret key, if someone intercepts that key, they can then decrypt the data. An example of this is AES, Advanced Encryption Standard, and symmetric encryption is commonly used for encrypting large amounts of data quickly. Onto asymmetric encryption. This uses two keys, a pair of keys, one public for encryption and one private for decryption. Security advantage of this is that the public key can be shared openly while the private key remains secret. So only the corresponding private key can decrypt the data encrypted with the public key. And this process is slower because it is computationally more expensive and slower compared to symmetric encryption. What is the difference between HTTP and HTTPS? So HTTP is Hypertext Transfer Protocol, which is defined as a protocol used to transfer data, like web pages, between a web browser and a web server. Security-wise, it is not secure. Data is set in plain text, making it vulnerable to interception and attacks like eavesdropping. It is often used for non-sensitive websites where encryption is not critical, and the port is going to be port 80. For HTTPS, Hypertext Transfer Protocol Secure, it's defined as a secure version of HTTP that uses encryption to protect data during transfer, and it combines HTTP with secure socket layers, transport layer security. Security-wise, it is encrypted, ensuring data confidentiality, integrity, and authentication between the browser and server. It protects against eavesdropping and man-in-the-middle attacks. And this is used for websites handling sensitive information such as online banking, shopping, or personal accounts. So the port for this one is going to be port 443. The key differences of HTTP and HTTPS, starting off with security, HTTPS encrypts data, HTTP does not. Performance-wise, HTTPS may be slightly slower due to its encryption overhead. And trust-wise, HTTPS websites often show a padlock icon in the browser, signaling that they are secure. How do you get a certificate using HTTPS? So first off, you're going to choose a certificate authority, which is a trusted organization that issues the digital certificates. Next, you're going to generate a certificate signing request, CSR, which is a file that contains your domain name, organization information, and a public key. And this is generated on your server and sent to the CA, Certificate Authority. Next, the CA will verify your identity, and it will verify that you own the domain and or organization via DNS records. Next, you will receive the certificate. So once you're verified, the CA issues the certificate, which contains the public key, domain name, expiration date, and the CA's signature. And lastly, you just install the certificate on your server. So you configure your web server to use a certificate, which enables HTTPS and secure communication. What is a TCP handshake? A TCP handshake is the process used to establish a connection between a client and a server over a TCP transmission control protocol network. It ensures that both parties are ready to communicate and that they agree on the parameters of the communication session. So this process involves 3 steps, often referred to as the three-way handshake. Starting off with SYN, synchronize. The client sends a TCP packet with the SYN flag set to the server. This is the client's way of saying, I want to establish a connection. Then we have the SYN ACK, synchronize acknowledgement. So this is when the server responds with a TCP packet that has both the SYN and ACK flags set. This means the server has received the client's request and is ready to establish that connection. And last we have ACK, acknowledge. The client sends an acknowledgement back to the server, confirming that it has received the server's response. After this, the connection is established and the data can start flowing. Once the handshake is completed, the 2 parties can send data securely over the TCP connection, knowing that both ends are synchronized and ready for communication. How does TCP provide reliability? So TCP provides its reliability through these key mechanisms. Starting off with the first one, sequence numbers. This ensures that data arrives in the correct order. Second, we have acknowledgements, ACKs, and this confirms successful data delivery. Third, we have our retransmission, which resends lost or corrupted packets. Fourth, we have checksums, which is going to verify our data integrity. Fifth, we have our flow control, which is preventing overwhelming the receiver. And lastly, we have congestion control, which manages network traffic to avoid packet loss. How do you end a TCP session normally, and are there any other ways? So TCP sessions are normally closed using the 4-way handshake. Starting off with a FIN, one side sends a FIN packet to signal that it wants to close the communication. Then we have an ACK. This is the other side acknowledging the FIN. Then the second side is going to send its own FIN packet to close its end of the connection. And then the first side is going to acknowledge that second FIN. This ensures that both sides agree that the session is closed, although it can be closed in another way. It would be abruptly with a reset, and this is usually prompted by communication or security concerns. What are the different TCP flags, and generally what do they do? So starting off, we have SYN, stands for synchronize, and the purpose of this is to initiate a connection, and this is used during the 3-way handshake to establish a TCP connection. The sender sets the SYN flag to indicate a request to synchronize sequence numbers. An example of this would be the client sends a packet with the SYN flag to a server to start a connection. Next, we have ACK, acknowledgement. So the purpose of this is to acknowledge receipt of data. This indicates that the sender has successfully reviewed the previous data or acknowledgement. The acknowledgement number in the TCP header specifies the next expected byte. So an example of this is during a connection, every packet that is successfully received is acknowledged with this flag. Then we have FIN, which is finish. And the purpose of this is to gracefully end a connection. And this signals that the sender's intent to close the connection. Both sides, though, must exchange FIN flags to fully terminate that TCP connection. An example of this would be a client sets the FIN flag to inform the server that it has no more data to send. And lastly, we have reset, and its purpose is to abruptly terminate a connection. This is used to reset a connection due to an error, miscommunication, or when one party cannot process the connection. No further communications occurs after that reset flag is sent. So if a client tries to connect to a closed port, the server might respond with a reset flag. What is the difference between TCP and UDP? So TCP, which is our transmission control protocol, is a reliable, connection-oriented, and ensures data is received in the correct order with error correction and retransmission for lost packets. It's slower due to this overhead and is used in applications like web browsing and file transfers. And on the other hand, we have UDP, which is User Datagram Protocol, which is faster, connectionless, and will not guarantee reliable delivery or order. It's used in applications like video streaming, gaming, and VoIP, voice over IP, where speed is more important than accuracy. What is DHCP and what information does it provide? So DHCP is the Dynamic Host Configuration Protocol, and the protocol used by DHCP servers, which provides each user a PC with a temporary IP address to use each time he or she connects to the internet. DHCP also provides the IP address of the default router, which is a router to send packets to if it does not have more specific information for sending a packet beyond the local subnet. What is DNS and what are the different records you can get from DNS? So DNS, the domain name system, is a system that translates human-readable domain names into machine-readable IP addresses and vice versa. So this functions almost like the internet's phone book, allowing users to access websites and services using names rather than numerical addresses. And some of the different records you can get from it is A, which is address, which maps a domain name to an IP4 address. And then you have AAAA, quad A, which maps a domain name to an IPv6 address. Briefly explain recursive and iterative DNS queries. So a recursive DNS query occurs when a DNS client, like your web browser, asks a DNS resolver to fully resolve a domain name. So the resolver is responsible for contacting the other DNS servers if necessary until it finds the IP address or an error response like domain not found. The DNS resolver will perform all the steps required to find the correct answer and return it to the client, whether directly or by following multi-DNS servers. Now for an iterative DNS query, the client, usually a DNS resolver, contacts DNS servers one at a time and requests information. If a server doesn't know the answer, it will return the best answer it has, typically a referral to another DNS server. The client must then repeat that process with the referred server, so the client continues querying different servers until the answer is found or an error is returned. So in summary, recursive, the server does all the work and provides that final answer, and for iterative, the server provides a referral and the client will continue to query other servers. What is MTU and what is MSS? So MTU, the maximum transmission unit, is a value that indicates the largest number of bytes that can be transmitted in a single TCP packet. So the MTU includes the length of headers, and so the MTU minus the number of bytes in the headers equals the MSS, the maximum segment size, which is the maximum number of data bytes that can be transmitted in a single packet. A configurable MSS adjustment size allows your firewall to pass traffic that has longer headers than the default settings allow. How would you find the IP address information on a Windows host or Linux? So starting with Windows, you're just going to open the command prompt or PowerShell. You will then type ipconfig and press enter, and the IP address will be displayed under the IPv4 address field. And now for Linux, which I have an example on, you're going to open a terminal on your computer. You're going to type ifconfig and press enter, and as you can see that I highlighted on the screen, the IP address will be displayed next to inet.